Hello and welcome to Science Talk. I am your host, Jim Massa. So, are birds dinosaurs? Modern birds, some of you are probably aware of, can trace their origins to theropods, which is a small branch of all the dinosaur species that we know of basically pretty much a carnivorous group. And if you were to look at, say, the cassowary, it kind of looks like a dinosaur, doesn't it? It resembles very closely a lot of what of course, we never know exactly what they look like, but our best interpretation of what an extinct theropod dinosaur would have looked like. So, sparrows, geese, owls, hawks. What do they have in common with Velociraptor, with T-Rex, Allosaurs, Utah raptor? What do they have in common? They can all trace their origins to a bipedal, mostly carnivorous group of dinosaurs, as we said earlier, called the theropods. And they first appeared around 231 million years ago during the late Triassic period. Now, the Triassic period is the first of three major periods of the Mesozoic era. Mesozoic meaning middle life. And you first had the Triassic, that was followed then by the Jurassic, and then the Cretaceous period. And then when the big rock came tumbling out of the sky, you kind of wiped out the non-avian dinosaurs, ushering in what's commonly called the KT, the Cretaceous Tertiary boundary. So then ushering in a new era. So the earliest birds shared a lot in common with their theropod relatives, including feathers and egg laying. There were some traits, for example, sustained powered flight as opposed to gliding, that did separate or distinguish ancient birds from other theropods, and eventually came to define what we now think of as birds, the modern bird lineage. But of course, not all modern birds fly. Just take a look at the ostrich as an example, or the aforementioned cassowary, the kiwi. There's a whole bunch of birds that emu, right? They all do not fly. They can run fast, they can give you a hell of a kick, but a lot of them are just simply their body size is just too big to get airborne and stay aloft. So while all non-avian dinosaurs are extinct, have been extinct for quite some time, the question remains, are birds still considered to be true dinosaurs? Yes, they are. Now, I did do a video segment examining this about a year or so ago. If you want to see that original video, please do so. Click on the video tab and scroll down. It will say dinosaurs, birds are dinosaurs. So Dr. Julia Clark, who's a paleontologist, and her specialty is studying the evolution of flight. She's a professor with the Department of Geological Sciences at the University of Texas at Austin. And she basically says, birds are living dinosaurs just as we are mammals. So, she goes on to say the following: in spite of the physical differences that distinguish all mammals from other species, every animal in that group, living and extinct, can trace certain anatomical characteristics to a common ancestor. She's talking about this for mammals, and then she goes on to say, the same is true for birds. So if you look, for example, some of the features that are common to all mammals, the presence of hair at some point in in their in the life. Even baby whales will have hair when they're like born, and then eventually they're lost to create a better hydrodynamic situation for them. Most mammals have 7 cervical vertebrae. Sloth has 9. That's an interesting one. Presence, of course, of mammary glands, either where the milk is dispensed through a teat, or in the case of, say, the monotremes, it's simply a secretion onto the skin that the young then simply lick off the fur of their mother. In fact, mammary glands are really just modified sebaceous glands. So, so there's some of the features that all mammals have. Notice I said nothing about live birth because the monotremes lay eggs. Okay? But if you look at the marsupials and the placentals, they have some sort of internal development along the way, but not the monotremes. So Dr. Clark continued, they're firmly nested in that one part of the dinosaur tree, referring to the theropods. All of the species of birds we have today are descendants of one lineage of dinosaurs, the theropod dinosaurs. So I think at this point we now know it's the theropods. So now what makes a bird a bird? Modern birds have feathered tails and bodies, unfused shoulder bones, toothless beaks, 4 limbs that are longer than their hind limbs. They also have a bony plate near their tails called a pygostyle. Other types of extinct theropods had one or more of these features, but only modern birds have all of them. And that's according to Takuya Imaya, who is a assistant professor with the Dinosaur Research Institute at Fuku Prefectural University in Fuku, Japan. Birds also have another anatomical feature unique to them called a furcula. And the furcula is basically the fused clavicle bones. Now, what is the furcula? Well, if you ever have Thanksgiving dinner and you then, 2 people go and, make a wish and they see which gets the bigger part of the wishbone. The wishbone is the furcula. There was a primitive bird found in Japan called the Archaeopteryx, 120 million year old avian, that Imaya described in November 2019. So this is just recently published paper. It is the earliest known bird with a pygostyle. Now, before I go further, I want to mention another important anatomical feature that flight birds have, and that's called a carina. It kind of looks like a keel on the sternum, and so basically allows for attachment of very strong, powerful pectoral muscles that power flight. So going back to this specimen that Dr. Mai discovered, the preserved structure closely resembled a pygostyle of a modern chicken. In other words, some structures in modern birds can be traced back to some of their earliest ancestors. However, primitive birds still had much in common with non-avian theropods, said Jinglai O'Connor, who is a paleontologist specializing in dinosaur-era birds and the transition from non-avian dinosaurs at the Institute of Vertebrate Paleontology and Paleoanthropology in Beijing, China. That's a cool specialty. In fact, early birds were, quote-unquote, very dinosaur-like compared to modern birds, according to Dr. O'Connor. Some had long reptilian tails, Archaeopteryx, teeth and claws on their hands. Many theropod dinosaurs that were not birds had true feathers, which are feathers that have a central part down the middle and branching barbs. Now, that's important. Let's stop right there. Basically, what Dr. O'Connor is describing here is are feathers that are symmetrical in appearance. If you look at the feathers from birds that fly, they're asymmetrical. The central shaft is towards one edge. Think of when you look at an airplane wing, right? You got the curved top, and then you have a flatter bottom there. That's that creates a pressure differential to provide lift. Well, the feathers kind of also help do that. In fact, that's where we got the design, is by looking at a head-on look at the feathers, not just from above, but from head-on. And you can see that concavity as well as the asymmetry. So you have a leading edge and a trailing edge, basically. So therefore, that begs the question, what were the feathers, if they were symmetrical and obviously not suitable for flight, what was their purpose? Insulation. Feathers provided insulation. So paleontologists like to distinguish between the various animal groups through precise measurement of subtle variations in the bones and other fossilized body tissues, including any protuberances, tubercles, which are like a rounded bulge on a bone, for example, typically good for muscle attachment. And then, so they look at these morphological differences, and then they take this data and they create algorithms. And what the algorithms do is the algorithms then show, along with the DNA analysis, if they're able to get DNA so that they can sequence it, difficult with extinct specimens, but they then create what are called cladograms. And cladograms is a diagram, and it's a branch of analysis called cladistics. And basically, it creates a timeline, if you will, of the relationships of species and genera to other species and genera. I will probably do a video segment sometime in the future explaining what cladograms are, how they're constructed, and then how to look at the information that they contain. Basically, you have like some sort of a line, and you got branch off points there where you see the branch off point that indicates, say, a common ancestor. So the closer the branching points are to the specimens or the genera or species, what have you, in question, the more closely related they are. The further back in time, the more distantly related. That's kind of a quick summary of that. But it's really cool because it's showing the evolutionary relationship. I've mentioned this before, but if you ever have a chance to go to the Museum of Natural History in New York City, spend at least 2-3 days there. You'll need it. And then another day or two at the Hayden Planetarium right next door. Really cool spots. Probably my favorite places in New York City, along Lincoln Center. But they redid all their displays, all the paleontological displays. And for every organism that they're displaying, they have a cladogram associated with that organism. So you get to see its evolutionary relationship. They did a lot of work. Dr. Mark Norell is the curator there, is to be commended. Tremendous work. So if you're ever in the city, check it out. So the earliest known bird is Archaeopteryx, and which name literally means ancient wing. Now there are some other specimens that have been found since then that seem to blur this distinction, and because for a long time, there's a huge debate. Did Archaeopteryx, was it capable of powered flight? Was it capable of sustained flight? Or was it merely a glider? Did it simply climb up a tree and glide over to another tree? A lot of debate on that. And the debate was due to the anatomical features. It had a long tail, didn't have a pygostyle. It didn't really have the furcula. Didn't seem to have the carina. So there was, it had teeth, it had the claws on its wing, but of course it had the feathers. So there was a lot of features that when you look at it, it's like, well, that kind of looks more dinosaur-ish, despite the wing, than it does birdish. That word. But anyway, so there's quite a bit of debate in the paleontological circles. So the Archaeopteryx comes from about 150 million years ago. The specimens were found in what's now southern Germany. The organism weighed about 1 kilogram. and measured about 50 centimeters. So 50 centimeters, that's it's about something like that. So it's not a little sparrow. Fossil evidence showed that it sported plumage on its tail and body. The shape of its forelimbs and feathers also suggested that, now here they're saying it was capable of powered flight. Fingers, excuse me, it had the claws on the tips of its wings, and it had the long tail. Fossils of birds from the early Cretaceous period, which is 145.5 million to 65.5 million years ago, have been found in northeastern China. China lately has been turning into a treasure trove of really cool fossil specimens. So, for example, Confucius sornus, which lived about 125 million years ago, had a beak and long tail feathers. Some Confucius sornus fossils described in 2013 included, this is an important one, medullary bone. Medullary bone is a spongy tissue. Now, modern birds have hollow bones, but medullary bone is a spongy tissue that are found in female birds that are sexually mature. That's really interesting. Another piece of fossil evidence linking ancient birds to their modern relatives is through their digestion. There's actually been some what are called gastroliths that have been found, basically will be the stomach region of some of the large sauropods. Gastroliths are gastric stone. We've all seen birds pick up pebbles. Okay? They swallow the pebbles. And then what does it do? It goes into the crop and gizzard, and when they swallow food, the crop is a storage place, and the gizzard is a muscular organ there, and with the stones or pebbles in there, it helps grind the food down before it goes into the stomach for further digestion and absorption by the intestine. So birds don't chew the way we chew. The gizzard does the chewing for them. So when they found gastroliths with the sauropods, the obvious inference to draw from that is that these large sauropods had a similar setup. So we find that, but they also found earliest known bird pellet. How many times? Well, it's usually hard to see because they're nocturnal, but you see owl pellets, right? Owls go flying around. They silent attacker. They grab the rodents, whatever, swallow them whole, digest. What's not digestible, usually the bones and the fur, is compacted into a pellet, and the owl then regurgitates it, upchucks it. We've seen evidence of this. So that's kind of interesting. Now, Dr. O'Connor, back to Dr. O'Connor. One defining feature of birds is the ability to fly, requiring large forelimbs covered with asymmetrically shaped feathers and powerful muscles. I've already discussed that. She goes on to say, in the lineage evolving towards birds, most likely a lineage within the Troodontidae, which is a family bird like theropods. Flight is what separates birds from their closest non-avian dinosaurs. Probably also know the troodontid. After the evolution of flight, the small bones in birds' hands became reduced and fused to create this basically a stiffened structure. Look at a chicken wing, right? It's that kind of triangular bit at the end. When you peel away all the muscle mass, you got that little triangle. That's what she's referring to, that fused section there. And so this is a stiffened structure that supports the feathers of the wing, also known as the primaries. Right? If you see pictures, right, you see these feathers like kind of pointing up at the tip of the wing. Those are the primaries. They're very important in helping for directional steering. After the extinction of the non-avian dinosaurs at the end of the Cretaceous period, birds continued to evolve and diversify, developing more specialized features, such as related to flight, the carina, right, the keel of the sternum, powerful pectoralis muscles, which are used to power the downstroke during flight. So as the keel, the aorta carina, got deeper and deeper, we see an increase in the size of the pectoral muscles that can help power stronger flight. Today is about 10,000 bird species worldwide. So, and birds, of course, go from hummingbirds, right, all the way up to, ostrich, condor. Condor is the largest bird that can fly with a wingspan of well over 3 meters. Pretty impressive. But they still belong to the same group of theropod dinosaurs from which Archaeopteryx emerged from. So, next time you wonder what a dinosaur looks like, look at a hawk. Look at a seagull. Look at a gray jay trying to steal your lunch. When you sit, up here in Alaska, they're called camp robbers because they will sit there and they perch and they just look and watch and wait. As soon as you turn your back, if there's food, they come and grab it. Now, I wanted to mention a couple other things, and that further, and this is genetic evidence for the dinosaur-bird linkage. Within, and they've actually have done this, within chickens, there's actually a linked gene group, which is in all modern chickens, is turned off. But if you were to activate that gene group, you end up with a creature that has teeth in its beak, has elongated tail, and it has claws appearing on the wings. So if there were ever a cause for some sort of mutation where this gene group gets turned on again, we could go back to something like that. I find that rather interesting. Last thing I want to mention with respect to this is Dr. Robert Bakker. Back in the late 80s, he wrote a book called The Dinosaur Heresies. Really an interesting book. And he was one of the first paleontologists to make this argument about, that birds are dinosaurs. And he continues work on John Ostrom at Yale University. And he actually, at the end of his book, he came up with a proposed new classification method. Usually, when you look at classification schemes, the most specific is the species, then it's the genus, family, the order, right? Class, and then phylum, and then kingdom was the most general. Of course, birds are in the phylum Vertebrata, actually phylum Chordate, subphylum Vertebrata. And then the class today is Aves. Right? That's the class Aves. It's like class Mammalia, class Reptilia, class Osteichthyes, class Chondrichthyes, right? Bony and cartilage fish, the last two. Dr. Bakker proposed having a class Dinosauria with subclass Saurischia, which are the dinosaurs, non-avian dinosaurs that had lizard-shaped hips, and then subclass Ornithischia, non-avian dinosaurs with bird-shaped hips. So the bird-shaped pelvis evolved twice independently, by the way. And then, of course, subclass Aves. So you have Dinosauria with subclass Saurischia, Ornithischia, Aves. And you can even go further back where you have the Archosaur, which include the groups of the Crocodilia, the Pterosaurs, and Dinosauria, of course, which you then have the two major Saurischia and Ornithischia. So he proposed that, and of course these things take a little time, like 30 plus years. So far it hasn't quite caught on. I think he makes a good case for it. So that's for the paleontologists to decide. So I hope you found this a little interesting. It's something I have a personal interest in. So wanted to bring you kind of this, I haven't, to revisit this topic. Haven't done so in about a year or so. So I thought it'd be a good time to revisit this topic and share that with you. And if you want to see my original video segment on that, please check it out. I'll have a link within the video. Thank you for your time. Hello folks, this is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.